Welcome to our second video of Molarity example problems. Our next two problems that we're going to go over are a little bit more challenging. The first problem is commercial sulfuric acid is 96.4% H2SO4 by mass and has a density of 1.84 grams per milliliter. What is the molarity of the sulfuric acid? So this one's a little bit different. We're going to be taking into account all three things that we've been talking about: percent by mass, density, and molarity. So this is the only type of problem where we're going to start with a conversion factor. So in this problem, we're going to start with density. So for this one, our density is 1.84 grams of solution per milliliter of solution. So I'm going to go ahead and write that. 1.84 grams of solution per 1 milliliter of solution. So now I'm going to create our conversion table. And if we think about what we have to get to, we have to get to molarity, which is moles of solute per 1 liter of solution. So we have milliliters of solution, and it's very easy to go from milliliters to liters. So we're going to do that as our first step. So our conversion factor, which you should know by now, there are 1,000 milliliters in 1 liter. So since we're dealing with solutions, 1,000 milliliters of solution is in 1 liter of solution. So that allows us to cross out those units of milliliters. Now we have to get grams of solution to grams of solute. So we're either going, the only other piece of information we have is this one right here, our percent by mass. 96.4% H2SO4 means that we have 96.4 grams of solute in 100 grams of solution. So I want to get rid of grams of solution and go to grams of solute. So I'm going to put grams of solution in the bottom, and I know with our percent it's always 100 grams of solution, and our 96.4 grams of H2SO4 on top. That allows us to cross off our grams of solution. Now we can easily go from grams of something to moles, and we just have to calculate a formula mass. So our formula mass for H2SO4 is 98.08 grams. I want to get rid of that unit, so I'm going to put the 98.08 grams of H2SO4 on the bottom, and that's how many grams are in 1 mole of that substance. Now, if we cross that out, and we look at the units that are left over, we have moles of our solute over liters of solution. That is the molarity. So our answer is going to be capital M unit, which is molar. And when we do the math, you should get 18.1 molar. And our substance is H2SO4. And that's our answer. And this is an actual real-life example, because when we get sulfuric acid in with our orders during the summer, this is exactly what we get in: 18.1 molar H2SO4. It's 96.4% H2SO4, and that is the correct density. So this is an authentic problem. Our second problem says calculate the molarity of a solution made by mixing 25.0 milliliters of 1.50 molar HCl with 35.0 milliliters of 5.70 molar HCl. Now we can do this. It takes a little bit of work. We have the same substance, HCl, and we have 2 different volumes and 2 different molarities. Well, we can't just take molarities and average them together. We can take volumes and add them together, but we cannot do that with molarity. So in order to calculate what our answer would be, we have to look at both solutions separately. We have a volume and we have a molarity. If you remember, molarity is moles over liters. Well, we have liters in the form of milliliters. milliliters, and we have a molarity, but we're going to calculate moles. If we mix two things together, the number of moles are additive and the volumes are additive. Molarity is not additive. So if we look at our first solution, and we look that molarity is equal to moles over liters. If we rearrange that, we can solve for moles, and it's going to be molarity times liters. So the first thing we have to do is convert our milliliters to liters. Hopefully by now you can do that in your head. So for solution number 1, we're going to take our molarity, 1.50 molar, times our volume in liters. So we have to divide that by 1,000 or remove the decimal point over 1, 2, 3 places. So we end up with 0.0250 liters. I'm going to use significant figures in my calculation. So the number of moles we get should be 0.0375 moles of HCl. I'm going to do the same thing for solution 2. I'm going to calculate the number of moles we have. This time we have 5.70 molar HCl, and we have 0.0350 liters of that. When we do the calculation, we get 0.200 moles of HCl. So now that we have that, we can calculate our new molarity. These are the same substance, so we have moles coming from two different places, so we can add these moles together. We can add our volumes together. If we know how many total moles we have and the total volume, we can calculate a molarity. So for our new solution, we're going to have 0.0375 moles plus 0.200 moles over 0.0250 liters plus 0.0350 liters. Go ahead and do the calculation. Make sure that your answer is written to the correct number of significant figures and has correct unit and label on it. So when you calculate this, you should get 3.96 molar HCl. Make sure that that number makes sense. Since you're mixing two things together, this answer should be between the two molarities given, 1.5 and 5.7. We have a little bit more of the 5.7, so our answer is closer to that. You should always look and see, does your answer make sense? If you got something that was like 12 molar, that is impossible if you mix two things. This value has to be between them.